Welcome back to iReady Math for 7th grade with Mrs. Lloyd. This is Lesson 4, Session 3, Recognizing Graphs of Proportional Relationships. And in the past two sessions, we hit learning targets 1 and 2, and today we'll be focusing mainly on the third one, tell whether a graph represents a proportional relationship. You can look at this and see if you think these are the same, if there are any that are different. The try it on page 71. Josephine uses a graph to compare the cost of renting a car at two different companies. Josephine uses a graph to compare the cost of renting a car at two different companies. Is the relationship between cost and time proportional at either company? And how do you know? Well, what do we notice that both of these are? They're both straight lines. Do you notice anything else? How could we figure out if they are proportional? I think I'm going to make a table for each one. So company A is blue, so let me go blue. And the first point is 0, 0. And then at 1, 8. 2, 16. And I'll go one more. 3, 24. So what do you notice about these points? Looks to me like I'm multiplying by 8 each time. So that would tell me that that is a proportional relationship. They're both straight lines, so let's look at company B. Oh, it starts at 0, 8. 1, what's halfway between 8 and 16? That would be 12. 2, 16. 3, what is halfway between 16 and 24? That would be 20. Right now, I see that 1 times 12 gives me 12. 2 times 12 does not give me 16. And I also know that 0 times 12 does not give me 8. So B is not proportional. But A is proportional. And we know that our unit rate, or our constant of proportionality, is 8. So in this example, they also made tables. And now let's talk about the graph. Company A, the graph is a straight line. The line passes through the origin. And company B, the graph is a straight line, but the line does not pass through the origin. So did you notice that? Company A passes through the origin. Company B does not. That is important. So in connected, is the relationship between cost and time proportional at either company? We already did that. Yes, at A, right? Company A. And then how are the graphs representing Company A and Company B alike and different? What did we notice? They both have a straight line. But they didn't both pass through the origin. A passes through the origin, right? And I'm just going to write 0, 0 for the origin. Sorry. So the graph for Company B does not pass through the origin. Why does that show the relationship between time and cost is not proportional? If we go back to our table, let's go back to our table. In Company A, 0 times 8 gave us 0, 1 times 8, 8, 2 times 8, 16, 3 times 8, 24. But for Company B, 0 times, there's no number that we can multiply 0 by to get 8. 1 times 12 is 12, but this changes then. 2 times 8 is 16, and 3 times some number less than 7 is 20. So why does that show the relationship between time and cost is not proportional? Because we're not multiplying by the same thing, and there is no number we can multiply with 0 by to get 8. Number 4, the graph at the right shows the relationship between cost and time at Company C. How are the graphs for Company A and Company C alike and different? Well, what do you notice about they both pass through the origin, so that is the same. But Company A has a straight line, and is Company C a straight line? It is not. So what does that tell us? Is the relationship between time and cost proportional at Company C? No. And why is that? It isn't a straight line. So now we know that it has to be a straight line and has to pass through the origin. The graph of a proportional relationship will always be a straight line that passes through the origin. That is super important, because if you know that, it helps you with so many other things. And why does that work? Because when that happens, the ratios are all equal. And if you remember, when we only looked at tables, if we had equivalent ratios, we knew we had a proportional relationship. So in this case, the ratios are all equal. A straight line that passes through the origin, the ratios are all equal. So now you can think about all the models and strategies that we've discussed today. Describe how one of them helped you better understand how to decide if two quantities are in a proportional relationship. We've used graphs, we've used tables, we've also used equations. You can think about all of those strategies. Let's try this on our own. 6 people ride a bus to get to work. The table shows their travel times and distances. Make a graph to represent the situation. So in this case, we're going to put distance here and time on the y. And now we're going to need to plot these points. So I think I'll go, well, we know this is 0, right? Let's see if I can go 1, 2, 3, 4, so that the lines in between are like 0.5, 1.5, 2.5. And now we need to think how we're going to go up. Maybe I can go by 4s. 4, 8, 12, 16, 20, 24, 28, 30, 32. And that's my highest value, so that's good. And now let's plot the points. 1.5 and 12 would be right there. But I need just a point, not this line. So at 1.5 and 12, 2.0 and 16, so 2.0 and 16, 3.0 and 26, 3.0 and 26, which will be halfway between 24 and 28, 2.5 and 20, 4, 0.5, I'm sorry, and 4, and 3.5 and 32, 3.5 and 32. Is there a proportional relationship between the number of minutes and the number of miles? Do we have a straight line? It doesn't look like it, does it? The points are not on the line, so the answer is no. The graph doesn't give a straight line. The graph is not a straight line, we can say. Okay, let's look at this graph. Lines A and B are shown in the graph. How can you describe the relationship between X and Y that each line represents? Do they both start at the origin? That's good. And are they both straight lines? So can we say that both of these show a proportional relationship? I believe we can. And it looks like C says lines A and B both represent proportional relationships. Now we have several practice problems. Oh, nope, we got an exit ticket. Number 10. Naomi says that the graph represents a proportional relationship because it is a straight line. Is Naomi's reasoning correct? Explain your answer. It is a straight line, but does it pass through the origin? No. So the answer is no. It doesn't pass through the origin. And you could say 0, 0. It doesn't pass through 0, 0. Now we have some practice. The three graphs show different relationships between X and Y. Does each graph show a proportional relationship? We'll look at graph A. Does it pass through the origin? Is it a straight line? So yes, it is a proportional relationship. Graph B. Does it pass through the origin? Nope. So we know it's not a proportional relationship. In graph C, does it pass through the origin? Well, we already know that it's not a proportional relationship, and it's not even a straight line, so it's got 2 strikes against it. So only A is a proportional relationship. We're going to look at those graphs again. For number 1, is there a change you could make to graph B from the example so that it would show a proportional relationship? What could you do to graph B so that it could be a proportional relationship? What if we moved it down? Would that be a proportional relationship? Yes. So we could move the line down. Let's just say down to start at 0, 0. Or you could say at the origin. Graph C starts at the point 0, 2. If graph C was shifted down to start at the point 0, 0, would it show a proportional relationship? So if we moved it down and started at 0, 0, does it show a proportional relationship? No, because it's not a straight line. No. It is still not a straight line. Describe the graph of the equation y equals 6x. Well, we could graph points, but really, we know that it is a straight line. And because we know the constant of proportionality or unit rate is 6, we know that the straight line passes through 1, 6. Number 3. Apani is training to run a race. She records the distance and the amount of time she runs each day. Is the relationship between the distance and time Apani runs proportional? Make a graph and use it to explain your answer. Okay, we need distance on the x and time on the y. And I think I'll go by half. So that'll be 0.5, and this will be 1, 2, 3, 4, 5. And then the values that I need to get all the way up to over 40. So let's go, I'm going to go by 10, so that one is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. I think I can get my points on there. So we need to plot 2, 18. So 2, 18 would be a little less than 20. 3.5 and 31.5. So 3.5, 31.5 is a little higher than 30. 3 and 27. 3 and 25, 27. 4.5 and 40.5. 40, that'll just be about right here. Didn't mean to make that spot. Does it look like we have a straight line that goes through the origin? Looks pretty good, doesn't it? So we have a straight line through 0, 0. So we know that it is proportional. So it is proportional. Maybe we should write that. Number 4, which line is a graph of a proportional relationship? Well, we now know just by looking. This is a straight line that passes through the origin, so B is a proportional relationship because it is a straight line that passes through the origin. And you can write that. And we have one more. Dion plots points to show the time it takes him to swim laps on 2 days. Is there a proportional relationship between the number of laps and minutes? I'm going to expand this. If I draw a straight line, what's going to happen? Let's do the best we can. Does that answer our question? Is there a proportional relationship between the number of laps and minutes? No. The line will not go to the origin, will it? The line does not pass through the origin. Or 0, 0. That's all for today. Thanks for watching.